Hello, going through the 8-3 worksheet, dealing with the first four theorems, specifically dealing with actually the first 8 theorems dealing with parallelograms. Okay, it says the measure of one interior angle of a parallelogram is twice the measure of another angle. Find the measure of each angle. So again, remember a parallelogram kind of looks like this. And if I have one that's twice the other, I'm going to call this my 2x angle, and this will be my x angle. This will be 2x because they're across opposite one another, and this will be x degrees. These are all in degrees. Now I know that these two, since they're consecutive, according to theorem 8.6, have to add up to 180. So 2x plus x equals 180. 3x equals 180. X equals 60. So I'm going to have 60 degrees, 60 degrees, two of these, so 120 degrees and 120 degrees. So that means 2x would be 120. So here are my four angles of the parallelogram. This one deals with this parallelogram. We're told it's a parallelogram, so everything applies. GH right here is the same as this one, so it's 8. HJ is, again, if this was 8, this is going to be 16 for a total. Okay. Angle KIH. KIH, this angle is going to be the same as this angle because of alternate interior angles, so that's going to be 28 degrees. Measure JIH. JIH, this angle here is going to be the same as, well, these two have to add up to 180. So we're going to take 180 minus 84 and get 96. So this will be 96 degrees, again because of theorem 8.6. Angle KJI. KJI, so we're looking at this angle here. Okay, if this angle is 84, this angle has to be 84. So this is 84 degrees. And then finally, angle HKI. I'm going to kind of clean up the picture here. It gets a little kind of cluttered here. So angle HKI, this angle, HKI, this angle here, is going to be, remember this angle came up to be 96 minus the 28 is going to equal 68 degrees. 68 degrees, because we knew because of this angle was 96 from earlier. Alrighty, so this is 68 degrees. So some work there. What theorem can you show that the quadrilateral is a parallelogram? So this is kind of asking us what theorem makes this a parallelogram. Because I have parallel and congruent here and here, that's going to be theorem 8.9. Because of the bisecting diagonals, this is theorem 8.10. Opposite sides congruent, this is theorem 8.7. We could do two different. This could be 8.7 because of this, this, and this. Or It could be because of these are congruent and parallel. It could be theorem 8.9. So we could do one or the other. Opposite angles congruent makes it a parallelogram. So that's theorem 8.8. And this really is the same thing if you take a look at it. So this is theorem 8.8. Alrighty, so kind of using our theorems to determine whether or not it's a parallelogram. And last one here. Okay, what additional information would you is needed in order to prove the quadrilateral ABC is a parallelogram? Well, if I say that this is parallel to this, then I need this is parallel to this. So I need to know that AD is parallel to BC. Okay. If I knew that this was the same as that, I could do a couple different ways. I could say that AD is congruent to BC. That's one of two ways. Okay. If ADC, if this angle here was congruent to this angle here, then I would need these guys here. So I would say that angle ADC would have to be congruent to angle ABC. If we had DE congruent to EB, then I'd need this congruent to this. So AE congruent to CE. And if CDA, if this angle and this angle added up to 180, we would also need to know that these two added up to 180, these two added up to 180, and these two added up to 180. So basically, we'd have to have all consecutive angles. And that's good enough for that one. So hopefully this helped you get through the assignment.